All right, so this is our notation from our 2F, which is what we've been working on. This is the notation for the combinations. So just a look at this to review what we've been doing. We can combine two functions and get a new function by adding. Here's the notation for adding, subtracting, multiplying, and dividing. So try these problems here. We're using these two functions, f of x equals 5x plus 4 and g of x equals 2x minus 6. And then you're going to combine them. So you'll get 4 new functions by combining them using these operations. So if you're watching the video, you can pause the video here and try the problems, and then we will check over the answers. All right. So most of you, I checked your answers and they looked good, but we can go in more detail over any of these that we need to. Number 1, we're just adding these together. So this notation means we're doing f of x plus g of x. So we're just adding, here's f of x, 5x plus 4 plus g of x. So if we are adding or combining like terms, we would get 7x minus 2. So the adding one looked good. Number 2, this notation f minus g of x means f of x minus g of x, we're subtracting. So I would be doing 5x plus 4 minus 2x minus 6. So that would give us 3x plus 10. Okay, and I was glad to see most of you got that plus 10. Because if we're subtracting, we'd have the 4 minus the negative 6. Number 3 was multiplying. This notation means multiply, so f of x times g of x. And I saw some of you use the box method, or you could also use distributive property on this, and we should get 10x squared minus 22x minus 24. And then the last one was dividing. This notation, f divided by g of x, means f of x divided by g of x. So this one, some of you weren't sure what to do on this one. We would just put 5x plus 4 over 2x minus 6. And we can sometimes reduce or simplify, but in this case, we can't. Because sometimes there's a common factor. We could factor out and divide, but if we look at this 5x plus 4, there's no common factor that I could factor out. If it was like a 6x plus 4, I could factor out a 2. The one thing to remember on, so that's actually all we could do. We would just leave our answer like that. The one thing to remember on these is that this denominator can't equal 0. And so one thing we want to, or we should at least think about, I have a restriction on the domain on this one. This denominator can't equal 0. So you might remember we would set the denominator equal to 0 and solve. To solve this, we would add 6. So we get 2x equals 6, and then divide by 2. So we get x equals 3. But on this one, that's not what x can equal. That's the one number for this new function that x can't equal. Because if I tried to plug in a 3, I would get a 0 in the denominator, and we can't divide by 0. Okay. Does anyone want me to do any of the algebra for the multiplying or subtracting? I feel like adding was good. I feel like we were pretty good, but if anyone wants me to do any of them, it is definitely okay to ask. All right, so looks like we're pretty good with these. Obviously, sometimes our original functions could be a little more advanced, but at least we understand what the notation is and what operations we're asked to do. So let's look at the second type of way to put two functions together. Here, these are called combinations because we're combining two functions by adding, subtracting, multiplying, or dividing. The other thing we had was composing functions. First, I'm going to just review the notation, and then I'll put some new practice problems up. I'll bring some paper towels around in a minute for erasers. So with composing functions, hopefully you remember from before break, we have this little open circle like this. The way we say this is f of g of x. What this means, we can rewrite it like this, f, and then in parentheses, g of x. And so you might remember what that means. Here, the g of x is on the inside. So this means we're going to plug g of x into function f. Okay, and if it's written in the other way, like this, g of f of x, that's just the other way around. So the letters would stay in the same order, and we can rewrite it in function notation like this, g, and then in parentheses, f of x. So the difference on this one is we would plug f of x into function g. So instead of combining functions by doing an operation, we're plugging one function into the other. So like we did before, we'll actually go ahead and use the same two functions, but I'm going to have you practice now a composition of functions. I'll leave that up at the top so you can look at. And these are the two functions we're going to use, same ones we had before. I think we have 5x plus 4 and 2x minus 6. Okay, so first, I want you to find f of g of x. Okay, so go ahead and take a minute and try that one on your desk. I'm going to bring around some paper towels in case you need to erase what was on there before. I'm going to come around and help if you're not sure what this means. If you are not sure what this means, go ahead and write, at least write down these two functions at the top of your desk so I can kind of help you out. Do you want to go over this one together first and then try one? Yeah. Okay. I'm seeing right now numbering. Okay. Which shows me maybe on that, which shows me it was a good choice for you guys to come back in person. This is what we did on Friday or the Thursday before break, where we didn't where it was more like an online lesson where I didn't go over all the problems right away. I just went over them at the end. Okay, so when you see, as soon as you see something like this, I would rewrite it with function notation. So on number one, the way we say this is f of g of x. And so when we rewrite it, keep the letters in the same order, but we're going to rewrite it with function notation. So f on the outside, and then in parentheses, g of x, like this. So what that means here is the g of x is going to be our input, and we're plugging it in to function f. So here's what it's going to look like, and this is why it's sometimes useful to write those equations up at the top. So I'm taking g of x, this is g of x, 2x plus 6, and I'm plugging it in to function f right here where the x is. So I have, in this function, I have the 5 on the outside, and then in parentheses, instead of x, I'm filling in 2x minus 6, and then I have the plus 4 on the outside. Okay, so before we simplify, does everyone see where this is coming from? We took this and plugged it in for x. Okay, then we just simplify that. So to simplify this, I would just distribute. So we would have 10x minus 30, but then don't forget we still have that plus 4. So then I can combine those numbers. So we end up with 10x minus 26. Okay, so this is our new function f of g of x. That's the notation we use. So that this notation is open circle. Remember, it's not multiplying, it's plugging one function in to the other. So we plugged g of x into function f in this case. So let's look at it the other way around as well. And then I will you guys try a different one. All right, so you can also see it in the, if it's in the other order. So if you were asked to find g of f of x, this is the other way around. So again, you can rewrite that in the function notation. So keep the letters in the same order. And this means g is on the outside, and then in parentheses, f of x. Okay. So in function notation, remember whatever's in the parentheses is the input. So this is our input, and we're plugging it in to function g. Okay, so here's the difference here. Let me delete those. This time we're taking f of x. So this is our input. So I'm taking 5x plus 4 and plugging it in to function g. So I'm going to plug it in here where the x is. Okay. So I'm going to have the 2 still. And then in parentheses, instead of x, I'm filling in 5x plus 4. And then I still have the minus 6. Okay. So that's what it looks like in after we plug it in. Okay. So I took f of x and plugged it in here. After we plug it in, then it's just a matter of simplifying. So to simplify this, I'm going to distribute, so we get 10x plus 8 right here. And then don't forget, we still have that minus 6, so I could combine those. So our answer on this one is 10x plus 2. So this is g of f of x equals 10x plus 2. Okay. Hopefully now that looks a little more familiar. So we're plugging one into the other. So now I'm going to have you try one. We're going to try one with linear. So it'll be pretty simple algebra like this, and then we'll try one with a little bit more advanced algebra. All right. All right, let's say we have f of x is 3x plus 4, and g of x is 2x minus 1. And the first thing I want you to do is I want you to find, I'm going to number it a different number. You obviously don't need to number it, just for the people on home or at home. So let's say this is number 5. I want you to find f of g of x. So go ahead and take a minute and try that on your desk. If you want me to help you set it up, let me know. So this one is going to be, you can write it in one notation. You know, the letters stay in the same order. The leaders you can try to use this. That shows us right here. So what this means is we're using G of X, which is 4 minus 1, and so we want to here. So we have the 3 on the outside, and here instead of it, the parentheses we're going to 4 minus 1, and then we put 4 on the plus 1. So you are on the right track, but when we plug this in, so this one was the estimate, 3x plus 4. We're plugging it in instead of it, so there wouldn't it just be the 3 on the outside, so there wouldn't be this. And then we're filling instead of x, we're filling in 2x minus 1. So then when I do it, yeah, I think you added this together. Yeah. I don't have to write about this. So we have, so f of x is 3x plus 4 and 2x minus 1. And so in this case, f of g of x. Yeah, it's plugging it. Yeah, so we're taking it and we're plugging it in here. So I still have this 3. And then in parentheses, I have 2x minus 1 and then the plus 4. I think you added them together. Yeah, so we just plug this into that. Okay, good. You're at the next one. Oh, okay, yeah. One of them should be, I think you just have a sign there. Because this is a minus. Oh, okay. Yeah, and then you, yeah, you got it there. Okay. And catch up, everybody. So the first one is F of T X. So if I rewrite it, it's like this. The So that's the first. Yeah. The system will try. Yeah. So you distribute it. Yeah. Okay. So this one, whoops. We should have ended up with 6x plus 1. And that one we plugged g of x into function f. All right, some of you already did it, but I'm going to ask it in case you didn't do it yet. I also want you to do the other way around, g of f of x. If you already did, then that's fine. If you didn't, go ahead and take a minute and do the other way around, g of f of x. Yeah. You're plugging in this whole thing. All right, good. Once we do the first one, we got the second one pretty easily, right? Good. Okay. So this one was the other way around. We plugged f of x in the function g, and we should have got 6x plus 7 on this one. Okay. So I made the algebra purposely easy on this one, so we can just make sure we understand the concept. But now we're going to do one with one that has something squared. So we're going to have a little bit more algebra to do. So let's try at least one more today. All right. Let's say we have f of x equals 2x plus 3. And g of x is going to have an x squared in it. So let's say g of x equals x squared plus 3x minus 4. Okay. So go ahead and you can write those two functions down. We're going to do the same thing. We're going to plug one into the other. We're going to compose them. So number 7, you're going to do f of g of x. The algebra on that one should not be too hard. And then once you do number 7, you can also try the other way around, g of f of x. That one, your algebra, it's not hard algebra. Algebra you already know how to do, but because we're going to have something squared right here, you're going to have to use either box method or distributive property to do the exponents. Okay, so go ahead and take a minute and try 7 and 8. And of course, please let me know if you need help. Or if you want help setting it up. Oh, okay. Were you doing it in your head? Oh, okay. Yeah. Yeah, that's what, yeah, I think you were, so we have to say, okay, this 2x plus 3 squared, and then plus 3, and then in parentheses right here, we also put a 2x plus 3, and then we still have minus 4. And so don't forget.
Oh, so you do both?
Yeah, you have to put this all together. And then don't forget on the square part, you actually have to measure it out with either distributive property or box method. That's what it is. So remember when you're plugging in one, you're plugging it into the system. So it would, so right here, remember you can write this with like open parentheses. And so that I put open parentheses and go into next, but inside my open parentheses, I'm going to do it. So we're filling in instead of it, so not like next to it, but it would actually be the first square. And then here, I'd also fill in the square. Okay, so we're plugging, this is image setup. Here's our two functions. So as you guys see, here's plus 3. And is x squared plus 3x minus 4. So in this one, we're taking g of x, we're plugging this into g of x. So remember, in here there's an x, you could write it in open parentheses. And how's my battery already running low? So we have x squared plus 3x minus 4, and then anywhere there's an x, we're filling in 2x plus 3. And so to do this part though, we actually have to distribute or do the. Let me plug in my computer real quick to start that. Is this, which one are you doing? The first one? So the first one, we have, we're plugging, so for the G of X, so we're taking this whole thing and plugging it in here. So we sum up the two in front. Yeah, I just want to know the. Oh, no, yeah. All right. So on this one, are you good?
Yeah.
Okay, so on the first one, we have f of x equals 3. So number 7, we have f of g of f. So when you see this, you can rewrite it with the letters in the same order, but with parentheses instead. That way we can see that g of x is. So the first one, we actually don't have to use it. Because what this is saying is we're taking this whole thing and plugging it in here. Yeah. So 2x plus 3, but instead of x, I'm filling, yeah, I'm filling that square plus 2. So the other one, so this one is easy algebra. We just have to distribute. But the difference on 8 of x. So this time we're plugging f of x in. Now notice here there's 2 places. So here's our function x squared plus 3x minus 4. But for x, so this is so it looks like those 2x plus 3 squared plus 3 times 2x plus 3. So this part is squared. Remember we can square it actually. We got to multiply it by itself. So this is what we have to do. 2x plus 3 minus 2x. Another here, my point is that you have it's helpful if you choose your work on your chapter, so I can help you with this mistake. Yeah, I'm guessing they forget to log this. Okay, yeah, so that part was right, but then we have. You plugged it from that. Yeah, so you're also plugging. Yeah. So 3. Yeah. Yeah. And then go full in there. Okay. So I think I came around and tried to help everyone. So let's check over these. Number 7, f of g of x. This was plugging f of x, or sorry, wrong way. This was plugging g of x into function f. So it looked like this. 2 times x squared plus 3x minus 4 plus 3. And so here, that was easy algebra. We just had to distribute and then add the 3. So on this one, we should have got 2x squared plus 6x minus 5. And then on the other one, number 8, g of f of x. That one, I know I helped some of you set it up. But if you didn't get a chance to, if I didn't check your final answer, the difference on this one is we're plugging f of x into function g, but this one there's 2 places to plug in the x right here. Okay. So here it would look like this. In parentheses, 2x plus 3 squared plus 3 times 2x plus 3 minus 4. So this part we actually had to multiply out and either use box method or distributive property. Oh, I guess that's the bell for end of class. That was weird. Never heard that one before. All right, this one is 4x squared plus 18x plus 14. Okay, so on either of these two, if you needed help with any of the algebra, let me know so I could come help you. We'll have the live lesson like that and then until 8:40, so that belly ring signal from their class. But you guys are gonna stay in here for EMT for 25 more minutes. If I feel like, so EMT will be like it has been before. If I feel like we need full practice as a class, we could do that. If just a few of you need a little more practice, I can help you with that. If you're missing an assessment, this is the time when you can do those kind of things or get help on something from before. Otherwise, if you're generally caught up, you aren't necessarily going to have an assignment or anything to do during EOT. Obviously, most of you have your phones, but you can also like work on other problems or other homework or other things like that. Today, you don't have any assignment for my class. And I feel like we were doing pretty good with these. This is also when I have to take attendance for online students and check in with them. So, you know, I don't know how productive EOT will be, but we'll do our best. Okay, so for right now, you don't have any other assignments, but if you do want help with either the algebra on these, keep it on your desk so I can come around and help you in a few minutes after I check in with the online students.